All right, so this video is covering the do now from the 26th of March. So this is the original do now here with the challenges and the questions. Let's go and look at some of the answers. So it says, I think I'm hoping I see it. Mai and Noah also solved the equation, but some of their steps have errors. Find the incorrect steps in each solution. Explain why it is incorrect. So let's look at Maya. So let me get my tools going here so we can, there we go. So she has a couple options here. She could do a letter B, and if you have your chart, you already know that means to combine like terms. It looked like she took that option, so not bad. She has another option she can exercise here as well, and that's going to be letter C, applying distributive property. So do a little smart cut so we don't think it's addition, and then go ahead and apply. 3 sets of 5 is 15. Oh boy. Well, doesn't look like that works here. Looks like she kind of brings this down here, but she doesn't actually apply distributive property. And so notice the 5 is gone. So here it looks like she just magically makes the 5 disappear. Why? So that's their issue, okay? Let's go and take a look at Noah's here, all right? So once again, nice job with combining like terms. Letter B. 14x minus 2x, 12x. So we go over here. Okay, could apply distributive property. C. Smart cut here. All right, applies distributive property. 3 sets of 5, 15, and brings the x. Positive, 3 sets of 9, 27. So looking good so far. So what could she do next here? Looks like she took the 15x and did an A. Oh wait, the 15x goes nowhere else. So it looks like the issue here is that she just kind of, once again, magically made the 15 disappear on that side over there. Oh, actually, let's take a look. No. Oh, she does. She has a 15, but that's going to be 15 negatives. So let's take a look here. Let's erase this. So let's go back. So the 15 over here, so she has 12x plus 3 equals 15. Make that a little better. X plus 27. So we go here and I have 15 negatives, 15 negatives. And so I should have the difference of 12 and 15, or if you have 15 negatives and 12 positives, you have 3 negatives plus 3 equals 20. Bad looking 7. 27. That's her mistake. She doesn't subtract what she needs to do or use negative integers. She looks like she adds or uses positive integers because the sum of 15 and 12 gonna be 27. I put the X there so you know as well. Gonna be 27. So her mistake here is that she doesn't use the negative 15 when she goes ahead and does the letter A inverse operations. All right, so let's erase this. Let's go on to the next set of challenges here. So we had a series of equations here. Let's talk about how these equations are being worked on. So this one here shows you a different style of solving equation I hadn't shown you. So let's talk about this here, how they got that 4 plus 2x and all this stuff here. So what they do is they recognize that this term here, 12, has, the number 12 can have 4 sets of 3 in it. So if I was to go over here and I took 12 and laid out the factors of it, you would see it'd be 4 times 3. If I lay out the factors of the 3 here, 1 and 3. I guess you could put a 1 there as well, so I'll have you want to see that way. So if I go there and cancel out that factors that they have in common here, I'll be left with 4. So hopefully that makes sense of how that magically that went to 4, this 12 here. It wasn't magic. They actually went ahead and took the common factor they had and canceled that out. Took the remaining ones, 4 times 1, 1 times 1. You'll wind up on that, you get the 4. So let's go on and look and see how they got the 2x here. So we have a 6 as the coefficient. Well, if I go over here, 6. Let's lay that out. 2 times 3. And then over here once again, and I mean, we could put the 1 as well. I always forget that, sorry. And so what do they have as a common factor? They have 3 as a common factor here. So that's why the 2 here. Okay. So that's one unique style doing it that you can always use. I tend to just use the common factor one. I'll show you that one. I mean the common multiple one. And I'll show you that one on the next slide. Okay. So we'll go over here. I still have this 5 minus 9. Well, 5 minus 9 is going to be -4 because you remember, smart cut. 5 positives, 9 negatives. I'm left with 4 negatives. Now we do a wind up there. That's going to give me 2. And let's not forget it was an odd amount of negatives. So that's why we have the -2 there. All right, so a lot of work done in that situation. Okay, a little different than we do normally, but definitely can be done that way. Why don't I normally do this? Because you don't always get common factors here. If this had been, let's say, a 5, you can see where that doesn't necessarily help out. So that's why. All right, so let's go over here. We have, what is it? We have 4 plus 2x equals -2. All right. So at this point, I'm going to go ahead. It looks like they want to keep the variable over here and the number on this side. So let's go. That's an additional sign. Looks really bad. All right, so let's go over here and do 4 positives. Got it. 4 negatives. What I do on one side, I do on the other. So that leaves me with 2x equals -6. All right, so that's a letter A if you're using your chart there. And this is definitely FB baby time. Letter E, a bad looking E, but you get the idea. FB baby. Eyeball check. What's the coefficient? 2. That becomes the divider here. All right, what's the coefficient? Excuse me. What we do over on one side, we do on the other. So 2 there. All right, got my invisibile uno there for that wind up. And look, 1 negative. So 1 negative there. The wind up, and I have 3. So that's how they got that process there. I want to show you another way that we can solve these. Like I said, the way I tend to like that does a lot more. Oh, there we go. Let's see. So let's take a look at the way I took the same equation, I did it. With this equation, what I did was, with that same equation, I did something a little different. So let's see if I can I get my pencil? All right, there we go. So I did something a little different here. Notice, I did a letter D. I used a common multiple that they had in the smallest multiple that they had there. You can see once again, if I divide 3 into 6, I get the resulting 2. Over here, if I divide 2 into the 6, I get the resulting 3 here. So that's what's happening there. I get rid of those denominators, okay? So now, basically, I do a letter C, which is apply distributive property. Keep it in mind my smart cut. Then I go over here. This is combining like terms. So I guess you could call that a B as well. There. So we combine these like terms. If I have 5 positives and 4 negatives, I'm left with 4 negatives. Okay, so then we move down here. If I apply my distributive property, I'm just multiplying here to give me that answer. So I have 24 plus 12x equals -12. All right, doing pretty good. At this point, I go ahead and do an A, inverse operation, taking -24, and over here, 12 negatives, 24 negatives leaves me with how many negatives? 36 negatives. Last but not least, I finally get to do my FB baby here. And that's my solution. The same solution as the equation over here, but I just wanted to make sure that you saw how this can be a little more effective. Now, this has common factors, but this works all the time, even when you don't have common factors. All right, so let's clear this up, and let's go back. Let's see if I can go back or forward. Yeah, here. So let's look at the other equations, how they lay them out. So if we look at this equation right here, let me get my tools. If we look at equation number 2 right here, you can see what they did was they apply distributive property here and here. Let's do a smart cut so we're not confused by that. So notice, three, how many sets of 3 and 6? There are 2. How did I get that 3 over 6 thing? Well, 1/3 times, remember that 6 there? That 6 is a whole number. That's kind of weird. I want the numbers to be sort of similar. So you can see now they're similar, fraction numbers. And then we're going to go over here. 6 sets of 1 is 6. 3 sets of 1 is 3. Do my wind up like you saw right here. And that's how I got that 2 using that fraction there, okay? So let's go over here and see what they did in this situation. So they said 54. And keep it in mind it's negative. Negative is already there, but keep in mind it's negative. But I tend not to want to put them there because it throws me off a little bit. And then 3. How do we get to 54 over 3? The same process. 54 times the 1/3 here. So we do a wind up. And like I said, that's giving us 18 right there, okay? So we have 18. So now we're done with the fraction part. Let's go ahead and erase this. So, all right. So we did our C part here, apply distributive property. What are we doing next? It looks like we are, let's see here. Yeah, we're doing a letter A. All right. So if I have one negative here, I do the same thing over here. And that's going to leave us with, erase this. That's going to leave us with this right here. What do I have to do next? Another A. They're not showing that, unfortunately, but 18 positives. Take the same 18 positives over here for negatives. It has the final answer of x equals 14. Okay, so now I want to show you another way just using fractions to show you the fraction way where we use letter D. So let me stop here. And let's see if we can get to that equation number 2. All right, stop here. Take a look at number 2. So what I do with number 2 is I do a letter D. I go ahead and just take the largest common multiple and cancel out the fractions. Luckily, there's only one fraction, so I just use 3 here. So 3 is going to be the multiple this time, and notice I put the 3 over here. If I'm multiplying by 3 on this side, I must multiply by 3 over here. That might make you nervous, that 3 times that, so make it fractions. That gets you calmer. You know how I feel. You can put them all on one line. That can make, whoa. That can make things easier, okay? And you can see, cancel out. And so that's why we have automatically this 6 here, because this turns into 1 once we do that. So it brings down to 6, brings down to negative 54. And then over here, I'm going to apply distributive property as well. And that's going to give me, and let's see that uno there. That's going to give me 3x, smart cut, 1 negative and out of mouse, so negative there, 3 sets of 4, 12. So we went ahead and did D, went ahead and did C, and now we are deciding that we're going to keep numbers on the left-hand side and variables on the right-hand side. So I need to apply an A. Inverse operation on the variables. 3 positives, 3 negatives. On the number line, get you to 0. Arithmetic, 3 minus 3, 0. Remember, we do on one side, do on the other. Once again, that same idea of arithmetic or negative integers. That's going to give us that 3 right there. All right, so I know that I want to keep the variable on this side, but notice I still have this negative 54 here. So I need another inverse operation. 54 negatives, 54 positives, or 54 minus 54 is nothing. I take the same 54 positives over here, find the difference of that. That gives me 42, and it most definitely is time for E. FB, baby. So we go over here, do a wind up, and I get 14. So that's another way that you can find a solution to this equation. So I just want to keep in mind there are more than one ways to find solutions to these equations as you're seeing. Let's go ahead and go to the last one. Let's see if we can go that way. The last one here. Nope. So let's go here, last one. So the last equation there is pretty simple. It's basically what we've been doing, so it's not really too challenging. I think the thing that might throw some people off is this, the Invisible Uno. Notice -1 times 3 gives you negative, or an odd amount of negatives gives you negative. Over here, Smart Cut, 1 negative, 2 negative, positive, and one set of 12, obviously 12. So guess what? I had to do a C here, apply distributive property first. Okay, then after that, looks like I did an A. And that's how I got to this part here. Actually, let's go to the equation that I did. I'll make it a little easier because we do the same thing. So here, let's see if I can get to that equation. There it is. So let's go ahead and talk about that equation using what I did. So we'll go here. Notice I applied distributive property. You saw that. That's what happens. After I get done applying distributive property, I go ahead and combine. I do inverse operation because I decided one variables, remember, on the right-hand side. All right. My variables on the left-hand side. So 3 negatives, 3 positives. From on the number line, that gets me to 0. For arithmetic, 3 minus 3 is 0. So I go over here with my 3 positives. Well, that's going to give me 12, 12x. So once again, I want my variable on this side, and the number is over here. So I need to do another inverse operation. This time, not with the variable, but with the integers. And so you can see that if I go over there, 4 negatives, 4 positives, that gives me puts me at 0 on the number line, or 4 minus 4 gives me nothing arithmetic. So I go over here, 12 plus 4 gives me 16, or 12 positives, and 4 positives gives me 16 positives. All right, so some people might put that as your answer, but it's not fully simplified. What does 12 and 16 have in common? The largest number they have in common, a factor, it's going to be 4. If I was to divide 16 by 4, I would get 4. If I was to divide 12 by 4, I would get 3. So this is the fully simplified form of that. All right. I thought this would be a little easier and better for you to understand than that sort of process that they use. So we do a little more in-depth explaining. So that will do it for the do now. Hope that helped you out. If you have any questions, make sure you reach out to me. Thank you.